Hey guys, it's Mrs. Jensen, and today we're going to start our unit on solving triangles using law of sines and law of cosines. So today we're going to have our first intro into law of sines. And if you recall from earlier courses, solving a triangle simply just means finding all three angles and all three sides. So in the past, we have used trig to solve right triangles. And you probably did that back in geometry. Now we're going to use trigonometry to solve oblique triangles. And oblique triangles are just any triangles that don't have a right angle. So it's just non-right triangles. So we can use the law of sines anytime that we have two angles and a single side, such as if you remember your triangle congruency rules, we have angle, angle, side, or angle, side, angle. And those are pretty straightforward. We don't have really much to be concerned with as far as strange scenarios. But if you recall from triangle congruency rules, when we have two sides and an opposite angle, we can use law of sines. But when we had the triangle congruency, remember that gave us the angle, side, side condition. You can say angle, side, side. Bad word, so you're supposed to remember you can't say that. And the reason you can't use that for triangle congruency rules is because you can't always show that two triangles are congruent with just the angle and two sides. So in trigonometry with law of sines, you can use law of sines to solve for the missing angles and missing sides when you have one angle and two sides. However, you have to always check to see if you could potentially get two triangles that might work. And we're going to talk more about that one tomorrow. So just a few things. Let's remember a few things about triangles. So remember that the longest side is always opposite the largest angle. And the smallest side is opposite the smallest angle. And you'll probably recall learning about the triangle inequality theorem, which said that two sides have to add up to be greater than the third side. And so not every possible combination of numbers is going to form a triangle. So keep that in mind when you're solving these problems, because it is possible to get no solution. It might not work when you're given certain combinations of angles and sides. So you will get answers that are no solution. So the law of sines is simply setting up a proportion between your angles and the opposite sides. So as you'll see, you have A over sine of A is equal to B over sine of B is equal to C over sine of C, or you can flip-flop your equation and put the sine equations on the top and the sides on the bottom. And notice that we label the triangle with a large capital letter for the angle, and then the small letter is across from that angle, right? So when you're doing these problems, obviously you're not going to use all three at the same time. You won't use A, B, and C. You'll use whatever combination of angles and their opposite sides work to make a proportion. Also, you always need to make sure that your calculator is in degree mode. And a good way to check that, remember on your graphing calculator, you can hit mode and then make sure that scroll down 2 places and select degree and hit enter, and degree should be highlighted. But a good way to check it is just in your calculator, type in the sine of 30 degrees and hit enter. And as you know from your unit circle, you should get 1/2 or 0.5. And so if that shows up, you're good. And that's a good way to check it kind of quickly. Okay, so let's talk about using law of sines to solve some triangles. So the steps to going through these problems, first of all, you always want to draw and label your triangle. And remember, you're going to use capital letters for the angles, and then use the lowercase letters for the sides. every single time. And if you draw out the triangle, it will really help you to avoid making some pretty silly mistakes. And then we're going to use the law of sines to set up a proportion to solve for the remaining pieces. Always remember you want to round to 3 decimal places, and you want to wait until the end. Wait until the end to round, okay? So you'll probably remember that from doing right triangles, that you want to don't round at the beginning and then use that rounded answer throughout the rest of your problem. Just leave it in your calculator until you're completely finished with the calculations. And then the third part, which sounds pretty simple, but people forget it, is that, of course, if you have 2 angles, you can subtract the sum of those 2 angles from 180 degrees to easily find the third angle. Okay, so example 1, triangle ABC, we're given angle B is 28.7 degrees, C is 102.3, and side B is 27.4. So let's go ahead and draw our triangle, and we're going to go ahead and label it. So we have A, B, C, and I know B is 28.7, C is 102.3, and side B is 27.4. And so when I solve, I need to find side C, I need to find side A, and I need to find angle A. All right, so first thing, I'm going to go ahead and solve angle A, because that's the easiest one. So the measure of angle A, if I just say 180 minus 28.7 minus 102.3, I'm going to get 49 degrees. Okay, and then I'm going to put a box around my answer because these problems get kind of messy, and I want to keep everything nice and orderly. So now I can go ahead and put that into my drawing here, and it will help me keep track of what information I have and what information I can use to find the missing pieces. So now if I want to find side C, I can use a combination of the items that I already have to find side C. So I know that I have sine of 102.3 all over side C, which I'm trying to find, and then I need to use B, angle B and side B because I don't know side A yet. So I'm going to do sine of 28.7 all over the side, 27.4. Sorry, that looked like a point, but 27.4. And then to solve your proportion, remember that you're just going to cross multiply. So when I cross multiply, I get 27.4 times sine of 102.3 all over, I'm just going to go ahead and do this in one step here, 28.7, sine of 28.7, and that's equal to C. And so C ends up being 55.747. Remember, 3 decimal places. And I was given units. So I'm going to go ahead and put my units here. Feet. And then I can go back and put this in my triangle. And so now I have the only thing left I need to find is side A. So I could say I'm going to use the angle A, sine of 49 degrees, all over side A is equal to, and I could pick either of the options here. Let's do what they gave me. I always try to use what they gave me in case I made a silly mistake somewhere. 27.4. And again, I'm going to cross multiply. All right. And so I'm going to end up with 27.4 times sine of 49 all over sine of 28.7. And I'm going to punch all that in my calculator, and I end up with side A is equal to 43.061. And it was feet. Okay, so if I go back and I draw a box around my answer, now I've found the missing angle that I needed, angle A, and I have side A over here, and I have side C. So I'm all set. So I've solved my triangle. Just make sure you put a box around your answer, and again, just remember to round to 3 decimal places. Okay, so let's do another example. This one's going to be angle, side angle. So I'm going to draw out my triangle. And of course, never draw to scale, but just want to make sure we label the positions, the sides and the angles relative to each other correctly. That's the most important thing. So in this problem, I need to solve for A, I need to solve for side B, and I need to solve for angle C. So let's go ahead and get the angle first. So 180 minus 98 minus 43 gives me 39 degrees. So C is 39 degrees. And technically we should write measure of angle C is 39 degrees, but when we're solving triangles, it's fine to just use the uppercase letters and we know it's an angle. So now I can solve for side A or side B. So let's go ahead and we'll just use sine of 39 degrees, and I'll use side C is equal to, solve for A first, so 43 all over side A, and when I cross multiply, I'm going to get 22 times sine of 43 all over sine of 39. So I get side A is equal to 23.842. Okay, and now I can go on and do sine of C over the side C, so 39, sine 39 over 22 is equal to, and what else do I need to find? B. So I need to do the sine of 98 degrees all over side B. So you get the idea, right? 98 all over, divide by sine of 39. B equals 34.618. And again, just make sure that you have all 3 angles, which we do. There's my third angle, and all 3 sides. I was given 1, and there are my other 2, so I've solved my triangle. So just as we go on to solve one more example, when you're solving for your angle, you're going to set your proportion up the same exact way. Remember, at the end, you'll solve for angle C by doing the inverse sine. So if we do the inverse sine of that, and remember, you can do second sine, second answer in your calculator, and we get approximately 30.226 degrees. Also remember, if you get an error when you're solving on your calculator, it's probably a triangle that doesn't work, and you can get no solution. When we set this triangle up, we can set up our proportion, and we'll see that we end up getting sine of B is equal to 1.6603, and so on. So when I go to do the inverse sine of that, my calculator will give me an error. But I can see right away that this isn't possible because the sine of an angle has to be anywhere from 0 to 1. So this is a case when I would get no solution.